A rectangular sheet of paper measures to the nearest centimeter 16 centimeters by 9 centimeters. What are the least possible values of its dimensions? Alright, so the dimensions of the rectangle would just simply be 16 by 9. In this case, we talk in centimeters, right? So let me just put the centimeters here. 16 by 9 centimeters, right? Right, so the question asks, what are the least possible values of its dimensions? And based on all the available answers there, you could see that we're talking about the whole issue of approximations. You could see that we're talking about the whole issue of rounding off, right? So if we're talking the least possible values of its dimensions, right? I'll just go straight to the answer for this one, because in this one, that's probably the better way to do it. So the answer for this one is answer C, 15.5 by 8.5. So remember, when we're rounding off, the 5 is the key. So from 0 to 4, and we go with the smaller value. So in other words, in this case, anything from 15.0 to 15.4, we will take that as 15. And if you want to go to 2 decimal places, we could go as far as 15.49. That will also take us to 15. Anything from 15.50 straight up the road will carry us to 16. Same thing with the 8, with the 9, sorry, right? With the 9, we could go from 8.0 to 8.4. That will carry us to 8. If we take it to 2 decimal places, we go from 8.0 to 8.49, 8.00 to 8.49, that will take us to 8. To go to 9, we start from 8.5, and we go from 8.5 straight up the road. So in other words, because of that, from 5 up, we go to the next digit, right? Is a principle we apply when we're dealing with decimal places. Is a principle that we apply when we're dealing with significant figures as well. Right, so that in this case we're more in decimal places mode, because we're looking for the largest values that could approximate to the whole numbers. So if we're talking 16, sorry, the smallest value. So if we're talking 16, the smallest value is clearly 15.5, 15.5, 0.6, all right, 5, 4, 3, 2, 1, 0, and boom. Right, so this 5, 4, 3, 2, 1, 0, and boom! A rectangular sheet of paper measures to the nearest centimeter 16 centimeters by 9 centimeters. What are the least possible values of its dimensions? Right, so this question is talking about the whole question of rounding off. We're talking decimal places here. And the principle we're going to talk about is applied even when you're using significant figures. We know that if the digit we're looking at is 0 to 4, then we go with the smaller value. And if we go from 5 up the road, 5 to 9, we go to the larger value. So in the case of 16, where we're talking to 1 decimal place, we're talking 15.0 to 15.4, which would take it back down to 15. And then 15.5 straight up to 15.9. which would take it to 16. Same thing for the 9. In the case of the 9, 8.0 to 8.4 would take it back to 8, and then 8.5 to 8.9 will take it to 9. Now you could get a question like this conceivably as well to 2 decimal places, in which case we're talking 8.00 to 8.49, which would carry it back to the 8. Or we're talking 8.50 to 8.99, which would take you to the 9. Same thing for the 16. We could have 15.00 to 15.49, which would carry it back to 15. Or we could have 15.50 to 15.99, which would take you up to 16. Good? So again, as we're trying to do in all of these questions, we don't want to just grasp the answer. We want to grasp the principle behind the answer, so that if we get something similar to this, similar to the topic, whatever the topic that the question is addressing, you could apply the principle and get the result that you need to get. Alright? So based on that, the least possible value of 16 in this context would be 15.5, which means that either B or C would be the answer. But in answer B, you have 8.4. And 8.4, of course, will carry back to 8. So that wouldn't give us the answer we're looking for. Now, if you look at answer C, where you have 8.5 as the smaller dimension, then yes, 8.5 is the least possible value for the digit 9. So in this case, the answer is answer C, 15.5 centimeters by 8.5 centimeters.